Welcome all. In this lecture, we are going to discuss one more example, that is example number 11. So let's discuss it. Using the Routh-Hurwitz criteria, determine the stability of closed loop system and determine the number of roots of each equation that lies in the right half of the S-plane. So in this question, we need to perform two tasks. First of all, we need to check the stability of a system. The second task we need to perform is we have to determine the number of roots that lies in the right hand side of S-plane. So first of all, we will check the stability. For checking the stability, we have to form a Routh array, and first of all, for making the Routh array, we will find the coefficient of the even power of S and odd power of S. So the even power of S are S to the power 6, S to the power 4, S to the power 2, S to the power 0. So S to the power 6 coefficient is 1, S to the power 4 coefficient is 8, S to the power 2 coefficient is 20, S to the power 0 coefficient is 16. Here odd coefficients of S to the powers. So S to the power 5 coefficient is 2, S to the power 3 coefficient is 15, S to the power 1 coefficient is 16, then remaining is 0 only. Now let's form a Routh array. So highest power of S is S to the power 6, so we will write S to the power 6 here, then S to the power 5, then S to the power 4, S to the power 3, then S square, then S to the power 1, then S to the power 0 only. Since the highest power of S is S to the power 6, that is even number, so we will write even power of S firstly. So 1, then 8, then 20, then 16. Now S to the power 5, so 5 is an odd number, so odd power of S are, odd coefficient of S are 2, then 15, then 16 and 0 only. After this, we will perform a cross multiplication method to write the further elements of a Routh array. So 2 will be multiplied with 8, 2 into 8 minus 15 into multiply with 1, 15 into 1 whole divided by 2 only. So here we get 0.5 as a result, 0.5. After this, 2 multiplied with 20, 2 into 20 minus 16 multiplied with 1 whole will be divided with this 2, so we will get here 12 as a result. So 12 will be written here. After this, 2 will be multiplied with 16, 2 into 16 minus 0 multiplied with 1, so 0 here, whole will be divided by 2, so we will get 16 as a result. So 16 will be there, and remaining no column for further multiplication, so we will write 0 only. After this, we will perform the multiplication of 0.5 into 15, 0.5 into 15 minus 12 multiplied with 2, whole term will be divided by 0.5. Here we get minus 33 as output, so minus 33 will be written here. After this, 0.5 multiplied with 16 minus 16 multiplied with 2 whole will be divided with 0.5. So we will get minus 48 as output. Minus 48 will be written here. After this 0.5 into 0. So 0 minus 0 will be multiplied with 2. So we will get 0 as output. So 0 will be written here. Since no column for the further multiplication, so we will write 0 also here. Move on to the next step. Minus 33 multiplied with 12. Minus 48 multiplied with 0.5. Whole term will be divided by minus 33. So we will get 11.27 as output. After this, minus 33 multiplied with 16. Then 0 will be multiplied with 0.5. The whole term will be divided by minus 33. So we will get 16 as the output. So 16 will be written here. After this, minus 33 will be multiplied with 0. So we will get 0 only. 0 multiplied with 0.5. So we will again get 0 as a result. So 0, no column for further multiplication. So we again write 0. Move on to next step. 11.27 multiplied with minus 48. Minus 16 multiplied with minus 33. The whole term will be divided by 11.27. So we will get minus 1.15 as output. After this, 11.27 multiplied with 0 minus 0 multiplied with minus 33. So we will get 0. So we will get 0 as output. After this, 11.27 multiplied with 0 and 0 multiplied with minus 33. So again we will get 0 as output. Since no column for further multiplication, so we will write 0 also. Move on to next step. Minus 1.15 multiplied with 16. Minus 0 multiplied with 11.27, 0. Whole term will be divided with minus 1.15. So we will get 16 here. Then 1.15 multiplied with 0. So 0 will be answer. And 0 multiplied with 11.5. So we will get 0 here. Similarly 0 here and 0 here. So the Routh array is formed completely. Now we need to check that this system is stable or not. For checking the system stability, we need to check that how many number of sign changes are there. So just focus on the first column of the Routh array. Here 1 is positive, 2 is also positive. So no sign change. 2 is positive, 0.5 is positive. So no sign change. 0.5 is positive and minus 33 is negative. So here one sign change is there. Minus 33 is negative, 11.27 is positive. So one sign change is there. After this 11.27 is positive, but minus 1.15 is negative. So one sign change is there. After this minus 1.15 is negative number and 16 is positive. So one sign change. So total number of sign changes is equals to 4. So we can say that 4 roots lies in right half of S-plane. Since 4 roots lies in the right half of the S-plane, so our system is unstable. So we answered both the question, that is our system is unstable and the number of roots that lies in the right half of the S-plane is nothing but 4. Thank you. If you like my videos, then please press the like button and subscribe to my YouTube channel.